Hello everyone. In this video I'm going to show you how to simplify your Boolean algebraic equations. I'm going to assume that you have already learned what a Boolean algebraic equation is, but you're finding some difficulties in doing the simplification using the regular Boolean identities. So what I'm going to assume is that you already know these identities. 0 plus 0 equals 0, 0 plus 1 equals 1, and 1 plus 1 is 1, where this is the OR gate. And you know these identities as well for the addition, for the multiplication. Okay, and I'm going to teach you in this video how the way that I follow and the way that I find this the simplest to me in order to do this simplification. Okay, and as you are going to see, I'm going to depend on two main identities. Okay, I'm going to depend on the fact that xy plus yz, xy plus xz equals x multiplied by y plus z, where I factored out the x. Okay, and this is pretty known in the regular algebra. Okay, where you could prove it by distributing the x over the bracket, the parentheses. And the second identity is this one, which is the multiplication of these two brackets is x is equal to x plus yz. Okay, and the way to show this is by expanding the brackets. Pretty much you can see that there is some sort of similarity between these two identities, and the way that I memorize it is by changing the plus sign and the multiplication sign in this equation. So if you change the multiplication here to an addition, and you change the addition here to a multiplication, you pretty much get the second identity. Change the addition and the multiplication in both the right-hand side and the left-hand side of this equation, you'll get the second equation. That's an easy way to memorize it, although changing the multiplication and addition is not correct. Okay, so let me begin with these problems. I urge you to solve them, to stop the video and search and try to solve them by yourselves. However, you might find it, if you find it difficult, try to use whatever formulas that you have, whatever identities that you have. But if you found it difficult, you can have a look at what I'm going to do. So let me first begin with the first equation, with the first problem. We want to simplify f, which is equal to a, b, c bar plus a, b, c plus a, b bar. Okay, we want to simplify this equation. And okay, so if you look at this equation, what you could do is you find that here there is ab, there is ab, which is kind of a factor, common factor between these two terms. So what I'm going to do is that I'm going to factor out this AB. Okay, I'm going to factor out the AB. Okay, and what is remaining? What is remaining from here is the C bar, and from here is C. Okay, and then the remaining term A, B bar. Okay. So what is C plus C bar? If you have C, which could take either 0 or 1, and C bar, which could take 0 or 1, in that case you'll find that this is equal to 1. Why? Because if C is 0, then C bar is 1. The addition of 0 plus 1 is 1. And if C is 1, then C bar is 0, and the addition of 1 plus 0 is also 1. So this turns out to be A, B plus A, B bar. Okay? So what if I take as a common factor, if I factor out the A, B plus B bar, and I end up with the same thing, which is A, because this is multiplied by 1. Okay? So right now this function, it contained three terms. I was able to reduce it to one term using the simplification. Okay? Let's move on to the second problem. The second problem is a little bit more difficult. plus G, B, C, plus A, B, C bar, plus A, B, C bar. So if you go and try to work on this problem, the first thing that you might find useful is by factoring out the b from these two terms. So you might want to factor out the b. However, do not consider that always the first two terms are the terms that you should be starting with. Perhaps they're not. Perhaps you might find a simpler way. And actually it turns out that there is a simpler way to begin to start this problem, to start simplifying this problem. And this simple way is by looking at the second two terms. If you look at the second two terms, you'll find that BC bar and BC bar is common. So why do I factor out only B from the first two terms, although I could factor out two variables basically from the second two terms? So what I'm going to do is that I'm going to let B plus C go as it is. Okay, I'm going to leave it as it is. Okay, and then I'm going to open a parentheses and write B C bar, which is this. Okay, and then what is remaining from the first term is A, and what is remaining from the second term is A bar. Again, this BC plus this is 1 multiplied by BC bar. Okay? Because this is 1. Right? So, right now I could factor out the B, C plus C bar, okay, which is equal to B. Right? So if you have started with the first one, it will work as well. However, it might be a little bit more difficult or a little bit more lengthy. It will take more steps. Okay. So what we learned from this problem is that you should not begin with the first two terms. Just inspect all the terms that you have first, and make sure and pick up the two terms that have the most common variables. Okay, because this is going to reduce the number of steps for you. Okay? Let's go and have a look at the third one. Number 3. H equals A, B, C bar plus A bar, B, C bar plus A bar, B bar, C bar. Okay? So if you look at this problem, you'll find that A, B, B, C, you'll find the first two terms have those in common. And you'll also find that A bar, C bar is common with A bar, C bar. Okay? So you could take these two or take these two together. It doesn't really matter. I'll begin with one of them and I'll leave the second one for you to begin with. Okay? So what I'm going to do is that I'm going to begin with these two terms. And I'll leave it to you to solve the problem, starting by factoring out whatever that could be factored out from these two terms. Okay? So that's my starting point, these two terms. A plus A bar, B, C bar, plus A bar, B bar, C bar. Okay? And then which is equal to B, C bar, plus A bar, B bar, C bar. Okay? So here I can see that C bar and C bar are common, right? So what I'm going to do is B plus A bar, B bar, and then take the C bar. Where did this parentheses come from? I took the C bar outside, okay, that's the factor, that's the common factor between these two terms. And then what I'm left out with is, in the first term, is B, and in the second term is A bar, B bar. Okay? So if you look at this, you can basically make use of this identity. Okay? And the way that I memorize this identity is by distributing the addition over the multiplication. So I'm going to replace this bracket with B plus A bar, b plus b bar. Why did I choose, were I able to do this step? If you look at b plus a bar, okay, b bar, okay, and here I'm going to write x plus y z, which is equal to x plus y, x plus z. Okay, so I've written out this identity here. Okay, x plus y z equals x plus y, x plus z. So whenever you find x plus y z, you could replace it with x plus y, x plus z. Okay, so here this is on that form. So I could replace the x. I could replace the x with a b, y with a bar, and b and z with b bar. Okay, so x with b, so right here b, and y with a bar, so plus a bar, and then x with b, right, plus z with b bar. Okay, and this gives you these two brackets. Of course, I know that it is not easy for you to deduce this step. However, you'll be able to get trained on this kind of step, and the way that I memorize it is because I know that this could be reduced whenever I have a b and a b bar, and the b bar is multiplied by any other term. I know that I can reduce this step, and this comes by experience. Okay, so we're left out with this term, and let me solve this by putting the b plus a bar as it is, and the b plus b bar is 1, multiplied by c bar, which is equal to, I'm going to distribute the c bar over these two literals, so b c bar, okay, plus a bar c bar, okay, and this becomes the final answer, right? So the trick is to remember these two identities and try to make use any of them as you need. You might be able to replace x multiplied by y plus z with this, and you might be able to replace x plus y, x multiplied by y plus x multiplied by z by this term. So you might do this or do that, whatever you want. And the same goes with these two. You might be able to replace the right-hand side with the left-hand side, or the left-hand side with the right-hand side, depending on the problem. Okay? Let's have a look at the fifth example, at the fourth example. Okay? So example number 4, s equals xy z bar plus x bar y z plus x y bar z plus x y z. Okay. Of course, I do not need to write down these because they're just redundant. I do not need to write them in here. I just wrote down S and H and G and F. Okay? So in this example, it's not really clear which one shall you take as a factor out. If you look at the X here, you find that it is different. Y here, you find that it's the only common between these two. And X here, you find it the only common between these two. Okay. However, if you look at this term, this is the only term that could have two common variables with the other three. Okay. So if I take it, if I associate this term with that term, and then take it as and take whatever common factor that I can factor out, this will solve the problem. However, these two terms will remain as they are. We will not be able to reduce them. Okay? Similarly, if I take this term with this one, so I'll be able to reduce the expression. However, these two terms will not be okay. The fourth problem says that S equals xy z bar plus x bar y z plus x y bar z plus x y z. Okay? So if you look at this problem, you'll find that this term and this term, comparing them together, you find that the y is common. So only one variable. This term and this term, we have only the z common. Okay? This term and this term, we have only the x common. Okay? So only one variable is common if I take these two, or these two, or these two. However, if I take this term with that term, then I'll find that the z is common, the x is common as well, right? So it's very useful to take these two terms together. However, these two will remain as they are. So what do? Well, I need to take this term with this one as well. Well, if I take this one with that, then I'll end up having z in common and y in common. Okay? So z and y both are common, right? Between these two terms. So I'm allowed to take xyz with x bar y z, or to take xyz with x y bar z. Okay? Or also I could take xyz with that term. So I'm allowed to take this with that, this with that, or this with that. Whatever one you choose, it will work. However, when you take xyz with this one, those two terms will remain as they are. You won't be able to reduce them any further. Okay? So the best thing is that I want to take this term with that and take it with this one and take it with that one as well. So what do? The best thing is you replicate this term, xyz plus xyz. So I have actually replicated this term 2 more times. Why? Because I want to take this xyz with that term, and I want to take it with that term, and at the same time I want to take it with this term. So it doesn't really matter if you replicate it 2 times, 3 times, 4 times, it doesn't really matter. Because by the end of the day, you know that this term, whatever the values of x, y, and z are, by the end of the day, x multiplied by y multiplied by z is going to be either a 0 or a 1. So you're allowed to replicate these 2 terms. Okay? I'm going to take this with that, this with that, and this with that. Okay? Let's first take these 2 terms. What is common? X is common, y is common. So xy, z bar plus z, plus these 2 terms. What is common? Y bar, y is common and z is common. So x bar plus x, y, and z. Remember that here there is a bar, okay? Okay? Plus the 3rd term. what is common? X is common and Z is common. Doesn't really matter which one takes the bar. Okay, so this becomes xy plus yz plus xz. Why? Because I can, this becomes 1, I can reduce this to be 1, I can reduce this to be 1. Okay, and this becomes the final answer. How do I know that this is the final answer? Just by experience. xy plus yz plus xz, if you look at the first two terms, you find that you cannot take except the y as a common factor, you cannot factor out except the y. While these two terms you cannot factor out except the z, which will not end up with anything, you could try it by yourself. And you could factor out here between these two the x, which will not give you any other simpler final answer. Right? So as you have seen, you have done these. We have done these simplifications based on these two identities only. Okay. I personally prefer these two identities. I prefer this method. If you have any other method, you're allowed to use it. And pretty much you could discuss whatever. You could take whatever techniques that you have, as long as you can prove the identities that you are going to use. Then you could use them directly and try to simplify it in based on steps. Do not try to overlook the steps. Do not try to take less steps than you should do. Okay, write down each step as explicit as possible. All right. If you guys have any questions, please let me know, and I'll be happy to answer them.